Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video, part 6 of Fred's Left Hand, we're going to continue with some of the wiring. So in the last video, I installed the analog input modules and an MPU 6050 inertial measurement unit in the palm, and the wires come back on this cable. So I'm running an I2C bus on that. That's going to connect up to the pins on the end of this PCA 9685, and then I'm going to put a plug on the end so that I can run the wires for the power and control of the whole lot. So before I do that, let's remove the servo bed. I've already removed the screws out of this, which makes it easy. And you'll see I've actually got labels on my pull cord, so I know what wire or what cable does what. Now these screws that I've got to hold the PCA 9685 in are all M2.5s, and if I had some M2.5 nutserts, I would definitely be using those. And you can see here I've just got plastic that I've extruded in underneath using a 3D pen. That's PTEG as well. There was a rib through here for bracing, which I've removed, and I've shortened this rib down, which used to be present. I think I did that in the second video. Okay, when we look at these boards, they are actually labelled. So you can see I've got ground at the top there. OE is output enable, and it's held low by one of those resistors nearby, and dragging it high disables the outputs. Then we've got SCL, SDA, and VCC and V positive. Now V positive is connected to the green terminals up here for power, and is on the other side of the circuit protection if one is fitted. This particular board does not have circuit reverse polarity protection fitted, so just be aware of that when you're looking at different boards. Some do have the reverse polarity protection and some don't. I don't actually have one to hand that I can show you without it, I don't think. Right, this one does have reverse polarity protection, and that's that transistor. Up in the top here is our reverse polarity protection. This one doesn't have it, and it's, look, that transistor on these boards was probably undersized to begin with. A number of people have had these boards fail as a result of that transistor failing when the servos are drawing too much current. So I don't mind them without that reverse polarity protection. So we're going to connect our ground wire, and the wires coming through are in the same order as this board. So one with the pink stripe on it, which is this one here, the one closest to me on the wire. It's got the pink stripe. That'll go to this, that's V positive. Then we've got ground, SCL, SDA, and the fifth wire isn't connected to anything. So we've got here ground, SCL, SDA, and then VCC is actually the logic power for this chip, and it's second from the bottom. Now I did file open the cableway for where it passes through the wrist, so that one of these JST connectors can go through. This JST connector is 1 pin shy, so we don't use that V+, and we're not going to be using the OC either. So we're going to connect ground, SCL, SDA, and then the bottom wire will be going to VCC. Let's start preparing our wires. Now I don't need all this length. I do want a little bit of length so we can separate the wrist when it comes to aligning the gears later on. Before I cut this, I'll mark it. Let's start with our ground wire. Actually, let's just do all the ones we're putting in the plug. Right, so that's our 4 wires on. This one's our VCC. So our VCC is going to be down the bottom here. Okay, so the next one is going to be SDA, which is this terminal. This one is SCL. The next one we leave blank, that's COE, and this wire is ground. Goes in the end. So that will plug in like that. Wire can poke down here, and that can go there. Now the other thing we need to do is put terminals on here. Bent over 90 degree would be good, facing out this way, so we can then do our next cable in. And I have a small 90 degree strip. Okay, so our main power wires are going to go in there for servo power, and these ones are going to be our control. They will run down underneath the servo bed, come up and out through the opening up here. Now this is where I need to do a little bit of measurement on the cable I've already installed into the bicep, because somewhere in the bicep I will need to add one of these. This, by the way, is a 20 amp DC-DC converter. The idea behind this is I can feed 20 volt DC from Fred's batteries into these terminals and get 6 volts DC on these terminals at up to 20 amps. The reason for running the 20 volt batteries instead of, say, a couple of 6 volt batteries is, one, the power density available on those batteries. The second one is, if you run a higher voltage up to that switch mode power supply, the current in the wires going to the input is going to be a lot lower than the power coming out. We're talking about 3 point something times lower. The power coming out is 6 volts at 20 amps or 120 watts max, and at 20 volts coming in, 120 watts is 6 amps. So instead of 20 amps flowing through our wire, we're going to have 6 amps flowing through our wire. When it comes to voltage drop in wiring, all wires have a resistance of some sort. The larger the gauge of the wire, the lower that resistance is. You can increase the apparent gauge by doubling up your wires, so you can get more current through with a reduced resistance and therefore a lower voltage drop. If I can reduce the current, I also reduce the voltage drop, and so using the switch mode power supply, I can actually reduce it so that I'm running over a shorter distance with that higher current. Alright, so next trick is to measure up my cable that I've got in the bicep, trim it back to what I have left, what I need to go into here, and make sure I've got enough to go up the top. So I'm going to do that. Okay, so this is a bit of the ribbon cable that I'm using for Fred to go down from his back down through his arm. This is a 12 core 24 gauge. Now most ribbon cables like this one are a 28 gauge, which is a much finer, thinner cable. So this one's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15 cores wide as opposed to the 12, and you can see there's not much difference in the width. Certainly not 3 wires worth. And that's because this is a heavier gauge. Now I went with the heavier gauge to put into Fred to reduce voltage drop. You'll hear me quite often tell you that voltage drop is not your friend. There is a reason for that. So 4 of these wires are going to be connected to the terminals here. So ground, SCL, SDA, and VCC. The remainder can go into these 2 terminals, which is power for the servos. So that's 4 wires each. Now I might actually pull 2 extra cores out. If you remember, we had an extra core running down that we're not currently using. I might save 1 core for that and the other core for the OC, which is not currently being used. The original plan was to connect that to a pin on the Raspberry Pi that is Fred's brain, so I could shut down the outputs if I needed to. Alright, so I might use 3 grounds on one side and 3 positive voltages on the other. And with that extra pin here, I need to bring 1 core up to there. So I'm going to split them up to about this point with my thumb, which is about 100 mil. Just make it easier to see. So 1 core I want to split off is going to be our extra for down in the wrist or down in the palm if I need it. And I will leave the OC between the ground. So looking at the markings on this, I'm going to go with this side is going to be my ground side, my extra signal, my logic ground, OC, SCL, SDA, and then VCC. I'm going to trim that back to about there. Now, being a heavier gauge wire, this one is a little more challenging to crimp in. I do recommend it if you are crimping these. It is possible to solder them direct rather than crimp, but if you are crimping, get yourself a decent pair of crimpers. Okay, that's in. What I will do is put another little single socket on the end of this one so that I can plug that other wire in, and we might put a pin on that one to plug them together, and then we don't have to worry about it again. Now, like the socket crimps, these are the pin crimps. They work exactly the same. If I can find a bit of heat shrink around those. That'll work. I don't need a great deal. This is mostly for wire marking and indication. Well, I did have a third screw in there. I will endeavour to dig up another one and put in there. I can still get that when the board is in there, the servo bed. So this wire will run down through here and go out through this hole. And the servo bed will now fit back in here. Cool. So that'll do for this video. In the next video, I'll connect up. I'll actually align this servo and the gear in here and this drive shaft between that point and my gear. Then I'll connect all these into their appropriate places. We'll fit the servo that fits in here back into place and terminate all of our lines. I'll also put on the plug for this. Now what I'm planning on doing is using a pair of these. These are 6x2, so 12 conductor JST plugs. One side's going to use the pins, the other side will use the sockets, so that this can be plugged into a, this will be the pin side, and then we'll plug into the socket side inside the bicep. Inside the bicep will be this, so the wires will be broken out, fed into here and come back out and then into the plug. And if I need to, I can also then tap out at that point the logic control if I need to add another logic module in there at a further date. I'm actually seriously considering grabbing another MPU 6050, one of these modules, and mounting it in the bicep, and that way you can see the position of the bicep relative to ground as well as the palm. It will mean that I need to install this in Fred's back. This is that I2C 8-channel multiplexer, and that will give me the ability to run both the MPU 6050s separate to the ones that are already in the system, because you can only have 2 of them on a single bus. If you like these videos, don't forget to click on like, subscribe, ring that notification bell to be notified when the next video comes out. This is a form of support that costs you absolutely nothing, but helps the channel a great deal. If you'd like to help the channel further, I do have a Patreon account. There will be a link in the description, and you can join my long-term Patreons VIPs Go Lucky and Lorenz Berger, as well as my builder member Al Morales45 in supporting the channel. All of my Patreons do get these videos at least 2 weeks earlier, VIPs even earlier, depending on when they're produced. If you have any questions, either leave a comment below or you can join us in Discord and ask questions there. I do see the messages in Discord a little bit quicker than I do from YouTube, and I do respond to them as best I can. In the Discord I can also post files if need be. And we'll see you in the next video.